Today I'm going to talk about structure equation modeling, path analysis, and the next lecture maybe I will be talking about mediation, and then we are going to talk about other statistics, uh, various statistics tests we are going to see in R, like moderation, mediation, chi-square test, and various videos I'm going to bring one by one in this channel. So if you are interested to know more about it, you can definitely subscribe to my channel and support my channel. So in R, basically there are various libraries, and what you can do is you can download any library or any package for that matter. You can go here, install, and today basically we are going to use two packages. One is Lavaan library, you can see. So from here you can select down install, but now I have already installed, so I will not do such packages. You have to install once, then the software will work offline also. So I am in RStudio right now, so let us cancel this just to show you. Now let me go and call the libraries. Library Lavaan has come. Let us run this from here. Then another library which I would be using today will be semplot. That's it. Another one which I'm going to use is dplyr. Okay, I think, let me see from here. Look at the name, dplyr or something. dplyr. Yeah, this one, dplyr. Okay, already have installed it. I have to just call it. So forgot the name. That's it. Select. That's all about. Now we already have we have made our software ready for analysis, and if we have to add something, we can add later. Now today I am going to talk about, there is this Lavaan package. In this there is already a database about political democracy. So let us call upon this database. We will say view. Already it is there in the package, we don't have to download. It is for practice. So political democracy. Okay, yeah, let's come. let us run this from here. I will not use shortcuts so that you can see it. Sometimes I can use it. Control Enter is run. Now this is political democracy, which has come now, the database. Okay, now I want to see, let us go back here to my file. I will write question mark. I want to take help to tell you what it is. Again, political democracy and control enter. So we'll get a help here, I suppose. Yes. Okay, it is about industrialization and political democracy dataset. So let me expand this for you. Okay. Now these are some of the variables which we have to see. There are 75 observations of 11 variables. So I am sure you know what is latent variable. If you don't know, latent variable is a variable which cannot be observed directly, and there are certain indicator variables which can be observed, and those variables, by observing those indicator variables, we get the value of, or we measure the latent variable. Now let me help you a little bit on this. Now see what it is, what kind of what we are looking at. Try to understand this particular database. It is talking about 1961 expert ratings of freedom of press, freedom of political opposition, fairness of election, and effectiveness of elected legislation. How legal system is strong or not, elections were fair or not, political opposition is able to speak or not, press is free or not. So such kind of variables are there. So y1, y2, y3, y4 and y5 up to y4, it is about 1960. Similarly, y5, y6, y7, 5, y8 is for 1965, for 2 years, 60 and 65. We're talking about democracy in 60 and democracy in 65. And then last is 4 variables there, 4 variables here for 60 or 65 for democracy, and industrialization in 1960. So how these democracies are linked with industrializations for particular years. So how do we find, first latent variable will be for 1960, then the second latent variable will be for 1965 democracy, and the third one is the industrialization in 1960. So this is our model, this is our variables. So what could be our model? So let us see. Okay, I'm trying to explain more in more detail so that little bit some idea you get. So this one is over. So let me take one variable. It is a latent variable, so it will be round. In the path analysis, it will be round. observed variable is rectangle. So first variable, let us assume that it is democracy 60. Here 60. Second variable, latent variable is democracy 65. And one more latent variable we have, that is industry 60. Okay. Now democracy 60 has y1 indicator variable. Sorry for this thing, but it is, I am sure you are able to understand. Y3, so y1, y2, y3, three variables. Well, these will be observed, and democracy DEM 60 will be formed. Then y4 is also there. Then democracy 65, 1, 2, 3, 4, y5, y6, y7, y8. Okay. Now this one, industry, has three variables which are indicators x1, x2, and x. That's it. So we will measure 1, 3 by 4 to y6, y7, 5, 8 to get democracy 65. Latent variable industry 60 will get to x3. So democracy 60 has an impact. Our model says, industry 60 has an impact on democracy 60. Democracy 60 has an impact on democracy 65. And democracy 60, industry 60, or democracy 65. This is the variable. So this is one regression, this is second regression, and this is the third regression. Path analysis. One has two parts. One is measurement model, another is regression. So this is first measurement model. You have to measure it. This one. Second measurement model is this, and third measurement model is this. First we will do the measurement models, and regression is how much? This is 1, this is 2, 3 measurement models. And how many regressions we have? A path, B path, and C path. Okay, in this particular video, I'm not going for mediation analysis. That I will be going in the next video. Direct effect and indirect effect, and also bootstrapping. We will do it in the next video. So right now, let us understand this basic one. Once we understand this, then we go to the next level in the next video. So this is the basic idea. Okay. So democracy 60 is 1, 2, 3, 4, y. 65 is 4, 5, 6, 7, 8, and industry 60 is y, x1, x2, x3, like that. How many x are there? Let us see. 3. Okay. x1, x2. This is 1. This is the arrow. arrow is there. This is one directional, unidirectional. Okay, now we can see covariances also, like maybe they are having covariances, and this one is also having variance with itself. There is an error term because when we are measuring the exogenous endogenous variables, there will be error term. When measuring, there will be difference in exactly, we cannot measure it, so there will be an error. So that also has to be taken into account, and covariances also is the part of structure equation modeling, and we will do it at we will do that also in modification indices. Then we will fit the model. Now okay, now this thing is over. Let us go back to our file. Nothing we have done, nothing, we don't have to fear anything. There's nothing in this. This is a basic idea library, this, and that can be seen from here also. And once you do it 2-3 times, you know the name of the libraries. There's nothing in this. Now let us remove this because we have understood, taken the help. So now now what we have to do is we have to write the model. We have to write the model. So it's very simple. Just name, because it is an object oriented programming language. Everything it stores in an object, like a flash. It is storing in a flash everything, like a variable, like a space. So let us make a space and let us make any object. We can write anything. Let us write model name. We can write anything, or we can write model new. Okay, now we have to store it in this particular object, so we will write like this, showing arrow like this. It will go, whatever I write now will go in this. So there's nothing to fear all this. Then we have to write the model in the inverted commas. So first I will write a comment. If you put a hash, it will not be taken as a program. It will not be taken as a command. It is a comment for telling everyone what I'm doing. So first I told you, here you can see this. First we have to measurement models we have to define. So measurement model. First we have to do measurement model. Sometimes also called as factor analysis or confirmatory factor analysis. So we are doing that because it is based on theory. So it is confirmatory factor analysis. Mostly we are interested in CFAs. So let me take this example again. Anything, this is any name from my side. This is name is from my side. I can put anything. I can put zebra also. Nothing, there's nothing in this. It's a variable. It is a name of a latent variable name. So nothing to worry about that. So let us put my first variable. Okay, let me not put capitals, make it small only. Democracy 60. and then we do equal to and tilde. This sign S versus tilde. It's called. Okay. It's not coming yet. It's come. Then what is the variables here? We have already seen y1, y2, y4. Yes. So that means democracy 60 equal to and tilde is nothing but y1 plus, if you're finding it slow, you can increase the speed of the video. I'm doing it for benefit of all. You can increase the speed to 1.25 so that it goes fast, or whatever you want to increase if you want. So y1, y2 plus y4, y3 plus y4. These are 4 variables, indicator variables, which will make the latent variable. Then another one, I'm making it 65. Just make it a little fast. Okay, what is there in this? Nothing is there. Then we have to write the variables y5, y6 plus y7 plus y8. That's all. And then we have a third variable, related variable IND 60, industrialization 60 equal to tilde. Then this one is 3 variables as we saw it on the database or data frame. It is called x2 and x3. Okay, let me see it once. Yeah, up to x3. That's it. Up to y8 and up to y6, y5. Okay. y4, y8. It's okay. x1, x2 is okay, fine. This is measurement model. Now we will write again comment. Second step is what? Second step is structure equation modeling. We have to write the parts. Let us make it big. So instead of equal to tilde, we have to write only tilde. So first one is democracy 60 is linked with, okay, sorry, industry 60 is linked with democracy 60, like this. Okay. So industry 60 has impact on democracy 60. Democracy 60 is a dependent variable. Industry 60 is a independent variable. So it is always from left to right. It's written opposite. Let us write democracy 60 tilde industry 60. This is 60 as impact on democracy 60. This is 60 as impact on democracy 60. Okay. Democracy 60 is impacted from industry 60 and democracy 60. 65. 65 is impacted from 60, 62. Two arrows are coming this side, yes. So let us write this equation also. Yes. Democracy 65 is impacted by democracy 60 plus history 60. Yes, can we check it? Democracy 60 plus industry 60 is impacting democracy 65. Okay, now our structure equation modeling is over, but we also need to define covariances between the variables, the variance. But we will not write it now. We will check this, we will write this when we are fitting the model. Right now we have defined the model, specified the model. We have to fit it. That time we will do it. So let me close this one. Come to plots. Let me come back to the original one. Okay. So all this I have written, since our variables, our models are showing. Now object sem will make. Let us go to the next step. Again the same thing. We'll go into this. Okay. Yes, object sem. Let us name it object sem. And right, structure equation model function will call upon SEN model. Structure equation model, we have to write model name, which is this one, model name. Write down model it is case sensitive. Model new data equal to political democracy. Political yes, political democracy. So our structure equation model we have made out of this as per the what we have specified. We have fitted this model in the structure equation model now and put this structure equation model of this model in the object called object underscore sem. So this is nothing but we are saying that please, as per our specification of the model, whatever we have specified, as per that you do structure equation modeling of that and put it in object called object underscore sem. So this is simple, and then we run it. If there is no error, I'll be happy. Okay, it seems it's okay. Object underscore sem should but come here, which I'm not able to see. Can I run it again by selecting the whole thing? Yes. Okay, anyways, if I call for object underscore sem, we will see. Now, next step is to look at summary of this. Summary of object underscore sem. This is our object. In summary, we need our square object underscore sem. Summary means I want to know what does this model, but this particular model is going to do. So summary of this structure equation modeling which we have fit. We want to summarize this. Then we should have fit measures, fit dot measures. I think it's dot measures equal to true, and also r square we need equal to true. That's all about. So we need the summary. Let us now let me try to run this once. Should come. data frame, small y, all are small. Just clear it and then again run this. Now we've got our summary, which is about this particular structure equation modeling summary we need. We want to fit the measures and we also require R square values. So let us see this particular. Okay, then we start from the beginning. What is this? Okay, this is maximum likelihood method. Lavaan takes maximum likelihood process. Okay, number of observation and everything. Over here it is chi-square is there for our model. It is 0.002, which is less than 0.05. Generally in statistics we are, we want p-value to be less than 0.05, but in structure equation modeling we don't want it to be less than 0.05. It has to be more than 0.05. We want to retain the null hypothesis. What is the null hypothesis for this particular chi-square is that it is a good fit. Null hypothesis is a good fit. The data fits the model. But if it is less than 0.05, it is saying that it does not fit. The model does not fit the data properly. So it's not taken very seriously, but it is important. Then test statistics, okay. Baseline model, fine. Okay, CFI and TLI, it should be above 0.9. So it is okay. Then RMSEA should be less than 0.08, but it is 0.1. More than 0.1. Not okay. Again, SRMR should be less than 0.08. It's okay. So this is not okay. 0.101 RMSEA. Okay, all are significant. The indicators. Regression is significant. It's okay. R squares, okay, highest is 0.94. It is having good impact. Fine. All these things we have seen, but it is not fitting as what we want. So let us try to fit the model so that it fits the indices properly. Now we can get modification indices for object. Obviously the same thing become object, same underscore same, and so what I want is that I want the modification indices particular order. I want to sort it, and So to sort it, right, sort. So let us try to see the modification indices. Here it comes, modification indices. So these are the MI modification indices or index. So if we have this particular y2, y6 is highly modified, it is having a huge correlation, 9.279. So let us try to y2 and y6. Let us put it in the model so that it is becomes 1. y2 is double. Double tilt y6. Now we do y6 and y8. As you can see here, 8.668. It's very high again. So put it y6 double tilt. Okay, it's not coming. Okay, y8. Then I can also put y1 and y5. y1, y5. That's it. I think let us try for this particular one. These three are enough as of now. Then let me again run the model. First let us clear this so there is no confusion. y6. Oh, again I think I put it wrongly. Y should be small. Should match the variable name properly. So that was the error. Again, let me put it back. And here it comes. Notification indices I want. Put it. It's taking time. Okay. Now let me see what is the scene. Have the model fitted or not properly? Now we have to see again. See summary, not modification. This is see the summary of it. Yeah, that's it. Let me see this. So let us see the chi-square. It is above 0.05. Wow. Wow. It's not wow. It is chi-square. If it is not favoring you also, then we will go for TLI and CFI. It is okay. Then we can see SRMR should be less than 0.08. The model is getting fitted. I'm seeing the 5 indices. There are many more also. You can see that. But when you're reporting to the research paper, 5 are enough, which I'm taking into consideration. And okay, it's significant, no problem. Square R. Okay. So now our model has to be better, and so I can stop modification indices now. Now I don't want to do any further, just covariance stuff. And that's all about. And also, yeah, now we have to see the diagram. That is the main thing also. So let me plot again in case it not started. Test on this. Now we have done same parts. Okay, let's come. Then we write about object underscore sum, and this we need the standard coefficients. So I will write standard coefficients. Then I need I want to have layout to, it can be tree, it can be spring. So let us write spring. Then I need the background color BG black. Okay. Now I also want, it should not fade out. R will fade out the ones which are very higher values. It will be stronger color. The one which will less value impact, it will be less very faded one. I don't want that. It will not print properly then. So I'm writing. But if you want it digitally, it is good. Fade is equal to false. Background black so that the thing comes properly. Without spring. Okay. I think that's all about. Let's try to run this. Incorrect number of dimensions. Okay. Try to put this. Down. This is yes. Now this is a latent variable. Yes. Y1, Y3, and Y2. And this one independent industry 60, X1, X2, X3. Layer of tokens, to fit the model. There are two cool ways. It's also showing the values of the positions. This is the error terms. I hope you like the presentation, and next one will be on mediation, effect, direct effect, and the best part R is that it can find a specific effect. Okay, which mediation is having, I mean, there are two mediators, then which effect is stronger. It can calculate the significance and everything. So some flexibility is there in R. So as of now, I am closing this particular presentation. See you very soon. Thank you. And please, if you like the video, to support my channel, please subscribe and like and share. Thank you.